Intelligent Transportation Systems Podcast. Hello everybody! Happy New Year! Welcome back to the ITSPodcast, the online periodic publication where you can feed your curiosity about intelligent transportation science and engineering. This is episode 9 for January 2014. I'm Javier Sanchez Medina from the IEEE Intelligent Transportation Systems Society. We have assembled a really informational episode, including a striking interview to Professor Alberto Broggi from Vislab about the recent groundbreaking accomplishment on autonomous driving. It's really instructive. We also have a transportation history section, this time about bicycles. If you have attended the recent ITSC 2013 conference in the Netherlands, you must have noticed how popular is this sustainable transport there. You want to know why? Just keep on listening. The news mini section is somehow related to bicycles too, including a promising new transportation mean. This is pretty much a menu for this episode. Get your tea or coffee cup, lean back in your armchair, and enjoy.
This is the news mini section for episode 9, January 2014. According to a recent IEEE Spectrum report, last summer, Organic Transit, a small company in Durham, North Carolina, has started manufacturing a new type of transportation. Combining bicycles and electric cars in the same vehicle, Organic Transit is introducing electrically assisted tricycles with a light, attractive plastic frame. Please check out this podcast website for having a look at this, probably groundbreaking new solution for personal mobility. Finally, here is another piece of good news. Mary Barra has been named to be the CEO of General Motors, the very first woman engineer to lead that huge car maker. We applaud Barra for demonstrating that talent and goodwill always makes the best candidate for the most difficult jobs at every level.
Transportation in history. Not many people know that there are more bicycles than residents in the Netherlands, and for cities like Amsterdam or The Hague, up to 30% of all journeys are made by bike. According to the 2011 European Commission Future of Transport report, which asked 1,000 Dutch citizens about their main mode of transport for daily activities, 31.2% answered a bicycle. This is just a little behind of the 48.5% of car users and way ahead of the 11% of public transportation users. There is a historical reason for this. There was a tradition in the Netherlands of using bicycles that changed as the use of private cars became really popular in the 50s and 60s. That increased use of cars caused an alarming number of road fatalities, reaching levels so terrible that 450 children deaths were reported in 1971. These strategies ignited a strong social movement called Stop the Kindermoord or Stop the Child Murder after an article written by a journalist whose child was killed by the car. The movement coincided with the oil crisis of 1973. So both things together moved the Dutch government to invest in planning safe bicycle routes all through the Netherlands. As a result of this investment and planning, you can now see many times completely separate pathways for bicycles and cars. People of all ages use bicycles. They have huge bicycle parking lots conveniently organized, and in summary, Holland is a bicycle paradise. And all of this happened with a reasonable budgetary effort behind it. According to the United Nations Environment Programme, the Amsterdam government has spent $160 million from 2006 to 2010 on bicycle parking and safety. That is not a big sum in comparison, for example, with the $40.3 billion that the USA federal government invested for highway and bridge improvements in 2013, according to the latest Surface Transportation Authorization Law titled Moving Ahead for Progress in the 21st Century. Perhaps there is something missing in this financial comparison. Perhaps we should also think about the public health savings of all of these Dutch citizens riding so many kilometers on their bicycles instead of polluting the air they breathe. Do you know what is Proud 2013? If you are a fan of vehicles that can drive by themselves, you will enjoy this. Let's jump now to Parma in Italy, where there's much more than fog and delicious food. Here's today's interview. Okay, we're today with Professor Alberto Broggi at his research center, Vislab, in the university campus of the University of Parma in Italy. Vislab is a world-renowned spin-off company of such university. Professor Broggi has collaborated with ITSPodcast a couple of times in the past, including its pilot episode, where we talk about the Intercontinental Autonomous Driving Challenge they accomplished on the summer of 2010, from Parma to the International Expo in Shanghai. If you want more information about that challenge, you can still listen to that first episode of the ITS podcast. Today, he has kindly hosted us here in Parma to talk about the different newer challenge they have produced to the amazement of the ITS scientific community. They have called it Proud 2013, standing for Public Road Urban Driverless-Car Test, but the name is very well picked because this is something to be proud of. Hello Alberto, could you please introduce yourself and explain to our audience about this new fascinating challenge?
Hello. Well, thank you very much for this introduction. I'm here a professor at the University of Parma and CEO of Vislab. And we've been testing our vehicles for a number of years. And this is our latest challenge. So the latest challenge is called Proud 2013. And Proud, we are really proud of the results of this challenge because that was the very first test on public roads, urban driving, and actually we even run a part of that without anybody behind the steering wheel. So the vehicle was really driverless in the real sense. And what we wanted to test was the performance of our system when driving downtown. And downtown in Parma is an Italian city which is kind of has narrow roads, a lot of roundabouts, traffic signs, pedestrian crossings and tunnels. So it's a very complex environment, and we wanted to test the performance of our vehicle there.
Alberto, from many conversations I've learned that Vislab has a strong interest on pushing on vision as the main technology for autonomous driving. In a previous episode, we interviewed two German scientists from Daimler and Karlsruhe University about another automated driving challenge they performed. That one still is also online if someone wants to listen to it. Alberto, it's interesting that these scientists are also more interested in vision than in other technologies like laser, radar, LiDAR, or even GPS. Why is that so? It seems a fragile technology regarding weather conditions, dust, night lighting, tunnels, all the funny foggy weather we have here today in Parma.
Yes, you're right. As a scientist, we like challenges, and this is a great challenge. We don't want to solve the problem with the easy sensors. I mean, I'm joking, of course. The main reason because we are doing this is that with vision, vision is it is an amazing sensor. With vision, you can get a lot of information, yes, you're right. It's complex because it doesn't really work in some conditions. But we would like to squeeze vision and see what we can get out of vision, and try to see if we can reach the very same level that you can reach with other sensors. With just vision. Of course, just vision is not the solution. You will need more than one technology to solve the problem, because when a technology has a fault, that needs to be backed up by some other technologies. But my own research and my group's research is mainly focused on seeing how much you can gain with vision.
Great. Alberto, for Proud 2013, your smart car needs to own a map of the song in advance. How precise that map should be, and how did you acquire it? Is that a limiting factor for this kind of experiments?
Yes, you're right. The current system that we have needs a map. It's not a detailed map. it's just we are using GPS, so it's a GPS map. So we know where the lane is, we know where our route is. But this is something that we would like to get rid of. So this is a kind of shortcut that we used to solve the problem and to run the test. But in the future, I'm seeing this. The need for GPS will still be there, but maybe we will have some coarse GPS or some lower resolution GPS, very low cost. And we would like to replace the high accuracy and high precision GPSs with vision. So this is what we are now doing for the future.
Alberto, you say in your website that 40,000 individuals died every year on European roads, and that behind of more than 93% of road accidents there is a human error produced by the distraction, driving under the influence of substances, etc. Alberto, for those listening to this podcast that have been affected in some degree by the car accident, it may be encouraging knowing that there is a smart bunch of scientists and engineers here in Italy trying to remove that risks from our daily mobility. What do you have to say? Is safety the first motivation for your work here in Vislab?
Definitely. The safety is really the first reason why we have been starting this effort, and we are continuing this effort. But remember, this is not the only one. This is the most important, of course, because we want to save lives. But there are other strong motivation that actually push for the development of autonomous driving technology and autonomous vehicles. And I would just like to mention some one of those. We are also working and bridging this technology to other fields. And one of those fields is agricultural. We are moving this technology into tractors, into implements that should carry on the field work 24 hours a day, 7 days a week without any operator on board. And this is again a new, that will be a revolution, I'm sure. So we have been talking about the revolution on the mobility, so on-road, car that drive themselves. This would be a revolution because we will be completely shifting the paradigm of mobility from the current mobility to a safer mobility. But if you apply that to the agricultural domain, then that would be a slightly different revolution, but still a revolution, because the possibility of having those autonomous tractors and autonomous vehicles on the field will allow a more efficient use of the land. And if you think about the huge fields in Brazil, in Argentina, in China, or Australia, if you had autonomous vehicles there that could run the field work for you, then that would mean boosting the quantity of food that you can grow, and that would mean really increasing the possibility of people around the planet to have food. So I'm thinking that as a much larger revolution than the one that we are going to see on the roads, because that will be not only saving lives because there will be no more accidents, but saving lives because that will be able to deliver food to people that are starving now.
Oh, that's exciting. It's exciting to be here and to touch these fancy cars you work with. However, there may be also listeners that view driving a car as a fundamental freedom, to feel that you are in command of such sophisticated and powerful device as today's cars are. Again, reading your website, you do a challenging and I could even say a provocative forecast. You say, no more personal vehicles. All vehicles will be driverless and shared. Do you realize that there is some reluctance even in the scientific community about accepting a future including just automated cars?
Yes, you're right. It's a provocative statement, I know. And if you want, it can be even more provocative, saying that one day it would be completely forbidden to drive your car or any car. Again, it's a provocation, and I'm not sure when it will happen, if it will happen. But I'm pretty sure this is the way to go. This is exactly how you would increase the safety level of our roads. Remember that when someone drives a car, it's a danger. It's a danger to him or her, but also it's a danger to the other people which are around. So if we really want to boost the safety of our roads, we need to find a way to remove the most difficult problem that we have, which is the human driver. As you mentioned, 93% of the road accidents are due to human errors. That means that the problem is the driver, and we need to either help the driver in the first stage or completely remove the driver, because that's the way to go. So I know there's a reluctance in thinking that all vehicles will be completely autonomous, and you will lose your enjoyment and that you usually have when you drive your car. But remember that there are also amusement parks, so you may be also allowed to drive your car and feel the power of your car. So enjoy speed and the control of the speed. In some specific areas would be just devoted to driving cars. So when you have to drive from home to work and to move, that should be done in the safest possible way, and that's with autonomous cars.
Mm-hmm. Let's get back to these new challenge details. How about this preparative? Is it easy for a scientist here in Italy to fulfill the legal constraints and do these kind of experiments? For example, those two German scientists from Daimler and Karlsruhe, they mentioned that there is that law in Germany since the 80s that allow experimental vehicles to drive in actual traffic. How about here in Italy? Is it easy?
No, it's not easy. Actually, we had to reach up to the ministry level to be granted the possibility of testing. And remember, this is not exactly the way others have been testing their vehicles. We have been running a car with no one behind the steering wheel. So that's really the first time ever that a car like that drives in a normal condition with normal traffic. So we had to reach up to the ministry level, get all the permissions from them, and also get the permission from the road authorities, the local police, the global police. So we had, it was very complex. And that reminds me when we drove from Parma to China 3 years ago. I know the technical challenge was nothing compared to the logistical aspects and compared to the permissions that we had to get, the driving licenses, the visas, the license plates, and all the logistical aspects that we had to take care of. So this was exactly the same. So here in Italy, it's not easy to do these tests. Actually, I'm coming from another demonstration this week. We had a demonstration in Denmark, and we were pretty much trying the same thing. So we were driving downtown in a Danish town. It was not as complex as the one that we delivered in Parma. But that was kind of complex, and the last part was driven without anybody behind the steering wheel again. And from my understanding, with the Danish, that was much easier for them to acquire all the required authorizations and visas to do that. So it depends on the country, but actually in our country, in Italy, it's not easy to do that.
Mm-hmm. And how about the autonomous driving you develop here? Is different from the developed in other research centers. Can you detail a little bit more about that?
Sure. We are all working towards designing and developing an autonomous vehicle. But the main driving motivation is different. So you know that the vehicle, autonomous car, is divided mainly in three parts. So there's perception, there's decision taking, and then there's actuation. All the scientists works in one of those or many of those three aspects, but not many of those really take care about other constraints that you may have. And I can just name some of them, like, for example, cost. So try to solve the same problem with the minimum cost. Or integration. So try to solve the problem with the best integration that you can have. But not only those, there are also redundancy. You should be able to solve the problem adding a sufficient level of redundancy so that the car, for any reason, if there is any fault in the car will notify that and understand that, and, for example, come to a complete stop or issue some kind of emergency maneuver. And there are also others, like, for example, security. There's security in it because we should, again, solve the problem, avoiding that some hacking from outside, from a remote location, would change the parameters of our vehicle, will change the behavior of the vehicle. So, again, the problem of autonomous driving is a challenge, usually divided in three steps, but there are more constraints that actually drive every single research center's research stream. And our research center is driven mainly by low cost and integration. So we are trying to solve the problem with the minimum cost and with a very nice integration. And if you have a look at our cars, they are all well integrated. You cannot spot the sensors on the car. We're mainly using low cost, so mainly cameras. And this is a kind of signature of our research stream, which is kind of different if you compare that with others which are using big sensors or very expensive sensors.
Oh, great. Okay, thank you very much. We now need to make a short break. Stay tuned. Hi there. It has just started. Do you want a new iPad? You can win it if you help us out a little bit by disseminating the ITS podcast. We are starting a new contest to find the best follower of this show. This is our way of thanking you, our listeners, for helping to grow this podcast by spreading the word. The contest is just opened and will be open until April 30. During this time period, we will determine who is the most active listener based on activities to inform others about ITS podcast. In order to be eligible for the contest, each entrant must send proof of his or her dissemination efforts to ITSPodcast@gmail.com. ITSPodcast@gmail.com. All dissemination efforts will be taken into consideration, but must be documented to be included in the contest. You can use your imagination. It's up to you if you want to go even beyond Facebook, Google+, Twitter, and LinkedIn. The contest winner will be announced on the May 2014 ITS podcast episode, at a special episode on the first anniversary of the show. Yes, the first anniversary. So don't waste another minute and start spreading the word around you. You will find this contest information in the ITS podcast website at itsp.cicei.com. Now let's get back to Professor Broggi and his fancy challenge, Proud 2013. We're back with Professor Alberto Broggi talking about Vislab's last challenge, Proud 2013. Alberto, autonomous or automated? There's such differentiation in the scientific community. Could you please put yourself in professor mode now and teach our audience what is the difference and where do you put Vislab's vehicles with this regard?
Yes, it's a kind of controversial because some people think one way, other people think another way, and usually the two terms, autonomous and automated, are slightly mixed. And but actually, you're right. Let's make shed some light here. So autonomous should mean that it's really autonomous, so it can really take decisions without any intervention. So it's really making its own decisions, for example, on route, and for example, on how to do with the trajectory. So it's really autonomous. So it does what it needs to do. Automated should mean that it's automating something which is pre-programmed. So if you have something which is already programmed, you run it, and that's the automation of some task. So this, again, controversial. Some other people think differently. But yes, it's nice to be talking about that, because this is usually in the media you see those two terms abused and used in some strange way. If you're talking about our vehicles, we're more automated vehicles. Even if actually we also use autonomous as when we refer to our cars, but we're more automated because we have a pre-programmed route, and within this route we have a limited autonomy, meaning that the vehicle has to take some decision, but it's limited.
Thank you for that. Alberto, since Vislab is a spin-off company, it basically has to survive by itself, economically speaking, right? So therefore, I learned that your company is using the science you have developed for producing a stereoscopic system that embeds hardware and software in a light device. What are you aiming at with this? The academia, also car makers, industrial applications, what?
Yes, you're right. We are now in let's say, the second stage of our first big product. So we have been working with stereo vision for a number of years, and we have also improved the algorithms that we use along with long tests. So now the version that we have is kind of robust, and we are very happy with that. So we have been thinking about freezing that system and make it available to everyone to use it. So now we have a version of our stereo system which is delivering disparity data, but also terrain reconstruction, obstacle detection, obstacle tracking. It's a complete system based on two cameras, and now it runs on a slightly small board, which is a PC board. It's kind of low weight because we have also a version which goes on aerial autonomous vehicles, so flying things. It's less than 1 kilo. But we're now moving towards the second version of that, and the second version is based on FPGA. So we have now already working in our laboratory a version of that based on FPGA. So the two sensors, which are hosted on a single board, will send the data, the images, to the FPGA, which does all the processing and then delivers the disparity image as the final output. So we are removing all the computationally intensive load and we're putting that into the FPGA. So the subsequent and the next step would be much easier. And this should be ready by early 2014. And again, we are willing to share that with other research institutes. And we already have some partners in this. We have been producing some of those prototypes and sharing with others so that we get their feedback and understand if there is something to add, to change, to modify, so that in the next version we will have some more robust system. And remember, this is a low-cost system because we have on a single board we have the two cameras, the lenses, the FPGA for the processing, and also a high-level processor to deliver the results out of the board. So all the processing is done on board.
For those not into autonomous driving, you mentioned that this device produces the disparity images. Would you explain that?
Yes, the disparity image is an image which is computed by two stereo frames. So when you take two stereo pictures, one from the left and one from the right, you can join them together, kind of compute a correlation between the two images, and then deliver a new image which encodes distance. And for every single pixel in the image, you not only have color, but you have the distance of the object which is represented in that pixel. So it's a kind of 3D point cloud. And the 3D point cloud that we generate delivers points in the 3D world, so X, Y, and Z. And the rate at which we process that is such that we can deliver about 3 million 3D points per second. And if you compare that with a laser or even a multi-beam laser, that's almost comparable to that.
Great, thank you for that. Well, we are almost finishing this interview, but I just wanted to know if you can share with us, with our followers, what's next. Could you give us a hint of your next challenge, considering the astonishing evolution of Vislab? Some of us are wondering, what's next? Space mining?
Okay, no, I know we are still recovering from all the demos that we have been given so far. So I really have no fresh news about our next challenges. For sure, we are now implementing a new car. There's a new car which is now haven't been advertised yet, but we have a new car. We are equipping that with a very nice set of sensors. And we would like to demonstrate that in 2014. So, yes, we do have something coming up, but still, I don't want to talk about that.
Okay. Professor Alberto Broggi, again, thank you very much for hosting the ITS podcast at your facility and producing this exciting interview. Please book us for your next challenge.
Sure, thank you. Goodbye.
Goodbye. We are closing now this episode. Don't forget about the best follower contest if you are interested in winning an iPad, or if you simply want to help out the show to grow a bigger community of followers. You have until April 30th. This podcast is sponsored by the IEEE Intelligent Transportation Systems Society, website designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain. Soundtrack developed by Rubicon. Language advisory by Manuel Arbelo and Professor Son Williams from Clemson University, South Carolina. We'll be back soon, bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.